All right, let's talk about what it really takes to build a massive solar project. And I'm not talking about a few panels on your neighbor's roof. I mean these sprawling, utility-scale power plants, the ones that cost billions of dollars. So, here's the big question, right? How in the world do you build a billion-dollar power plant when your fuel source, the sun, is, completely at the mercy of the weather? How do you make that bet?
Well, the answer isn't just about having the latest, greatest solar panels. It's actually much more fundamental than that. It all comes down to knowing your fuel, knowing it with almost unbelievable precision.
And look, you don't have to take my word for it. The International Energy Agency says it flat out. Solar radiation is the fuel. That simple idea is what everything else is built on: the engineering, the design, and most importantly, the financing. Just to be clear about the scale we're talking about, these projects regularly cost over $1 billion. And at that level, you just can't afford to guess about your fuel supply. You need cold, hard data. And that leads us to probably the single most important word in this whole business: bankable. All bankable means is that investors and lenders feel confident they're gonna get their money back. And that confidence, it doesn't come from a good feeling. It comes from data that proves the fuel source is solid. So what kind of data are we talking about? It's way more than just knowing a place is generally sunny. Investors, they need to see everything. They want to see decades of historic trends. They need to understand how the output changes with the seasons, how it changes day to day, and get this, even how it fluctuates minute by minute. Every little detail counts. Now, this obsession with precision brings us to a really common and really dangerous pitfall in this industry. Let's call it the average year trap. See, a lot of folks start with something called a typical meteorological year, or TMI for short. But here's the thing: TMI data was never meant for this. It was developed for stuff like designing heating and cooling systems for office buildings. It's basically an artificial year stitched together from a bunch of average months. It's like a greatest hits album of weather. And when you put them side by side, the problem becomes so obvious. A TMY dataset? It's fine for a small rooftop project, sure. But for a massive power plant? It's a huge mistake. It shows you a typical year that might never actually happen, and it completely ignores the real-world swings from a good year to a bad one, and crucially, it misses the extreme events. The worst-case scenarios that lenders lose sleep over. The bottom line is this: you could base your entire financial model on an average year, and then the debt comes due, and reality looks nothing like your spreadsheet. That is a very expensive problem. This is where the pros focus on a different number entirely. It's called the P90 exceedance. Forget the average. P90 represents a bad year. It's a number that you're 90% sure the plant's output will be higher than. It's that conservative, quasi-worst-case scenario that determines whether a project actually gets funded or not. Okay, now check out this graph because it explains everything perfectly. That wide, flat green curve, that's the uncertainty you have with just 1 year of data. The P90 value is way over to the left. It's low, which means high risk. But look at that tall, narrow blue curve. That's what happens when you have 10 years of data. The uncertainty just shrinks, and your bankable P90 value gets much, much higher. That is what gives an investor confidence. More data literally equals less risk. So it's pretty clear that deep, multi-year data is a must-have. But of course, the story doesn't stop there. The technology itself is changing fast, and that's actually making this whole data game even more complex, and the financial stakes even higher. For the longest time, solar panels only did one thing. They looked up at the sky. But now, we've got bifacial panels. These things are amazing. They capture sunlight from above, just like normal, but they also capture light that reflects off the ground onto their backside. So all of a sudden, the ground itself is part of the fuel source. And that reflectivity has a name: albedo. Getting your albedo measurement wrong is a really expensive mistake. We're talking a 10% error in your albedo data can cause a 2.5% error in your energy estimate. For a billion-dollar plant, that is a multi-million-dollar oops. So these new technologies are awesome. They're boosting production. But more production also means more variability, which brings us to the next giant challenge. How does the entire power grid handle millions of these new fluctuating power sources all coming online? And the answer, in a word, is forecasting. It is no longer a luxury, it's an absolute operational requirement. Grid operators need ridiculously accurate solar forecasts, from minutes ahead to days ahead, to do basically everything.
to keep the grid stable, to manage congestion so the power lines don't get clogged, to schedule other power plants. Without it, the whole system is flying blind.
Okay, so let's tie this all together. When you boil it all down, what's the big takeaway here? For making solar power bankable,
It's this. Good, high-quality solar data isn't just some technical detail for engineers to argue about. It's so much more than that.
It's the bedrock. It's the absolute foundation of investor confidence. And without that confidence, the billions of dollars needed to build our clean energy future, they just don't show up. So yeah, let's end with this one critical point from the IEA again. The bankability of the data itself is what makes everything else possible. It's what turns a plan into a power plant. It all starts with trusting your numbers. Which kind of leaves us with one last question to think about. You know, as the hardware or the panels themselves get better and cheaper, have we actually reached a point where the biggest financial risk in a solar project isn't the technology at all, but the quality of the data you choose to build it on?